I'm going to be exploring how we can use insights for ArcGIS to easily look at, compare, inspect data sets related to network performance for mobile telecommunication companies to see if we can get a better understanding of what's going on, and more importantly, to see if we can come up with a way of mapping how well our network is performing compared to how well we predict it's performing, because that is really important to us in terms of monitoring our network and finding areas that we might need to improve on in the future. The first thing that I'm going to do is I'm going to inspect some network performance event data that I've got in and around the area of Aylesbury. There's about 35,000 network performance event points here. Now within that data set, I've got a number of attributes, and Insights nicely breaks these out for me. So firstly, we've got a really nice temporal aspect to this data. So when did that event actually occur? Insights is really nice, and it breaks out those that date into key metrics that I might be interested in inspecting. For example, I might want to know the day of the week that these network performance events happened to see if there's patterns that we might want to look for. And here we can see that there is a temporal pattern, that generally speaking we see more network performance events on Fridays and Saturdays rather than during the midweek. And so when we think about planning, that's something that we might want to take into consideration, and in it itself is quite interesting. The other thing that we've captured in this data set is how close these network performance events are to their nearest cell site. So we can see there's any sort of correlation or patterns there. By adding that attribute as a histogram and up in the amount of bins, we can see that actually what we would probably expect to see is what we are seeing. We can see that closer to the cell sites, we're seeing less network performance events. This grows as we move away from it, and then tails off because we actually have fewer places in the UK where we are more than 8 kilometers away from a cell site, so you don't really find many of those. What's really nice is that we can interact with these charts and it updates the map. So where we have our most frequent number of network performance events, we can select that on the chart and see where on the map those things are actually occurring. It's just a really nice way of inspecting the data. Now, another way that we can start to make sense of this data, if you see, it's hard to kind of see the spatial patterns because there's about 35,000 points here and they're just all over the screen. It's hard to see what's going on, is we can actually join this data set to something that will make a little bit more sense of it. Something like postcode sectors. So these are nice polygons that will allow us to make more sense of all of these points if we can count them into the other one. Sorry, if we can count these points into the polygons. See if there's any spatial patterns. Now, the really nice thing about doing this is we're actually not only counting where these network performance events are occurring in relation to postcodes, we're also joining those data sets together through the common geography. So within this postcode sector, we've actually got some additional data, such as total population, that might be interesting to look at as well once we've combined those data sets together to see what's going on in relation to total population as well. So to combine these data sets, it's as simple as doing a spatial aggregation. You do that by selecting one data set you're interested in and dragging it over to the other data set, where you're provided with a few options, one of which is spatial aggregation. Now I'm going to leave this as the default settings and just click run. This is going to go off and it's going to count up these 35,000 points into those hundreds of thousands of postcode sectors and pull back the count of those into each postcode. And we can see that that's done that now, and we get back a result that is the number of network performance events per postcode. And if we just change that to be represented by a color rather than by those circles, now we can actually start to make a little bit of sense of this in terms of spatial patterns. The darker the purple here, the more network performance events are occurring. Now what's really nice is that actually we can, in the settings, normalize our data by dividing the count here at the bottom. Now the reason we would want to do that is this data set at the moment might actually just be showing us where lots of people live, not where we have abnormal areas on the network which are performing particularly bad. So if we divide this by that total population data set that we had, here we get a completely different picture, and a really interesting one. Once we've taken into consideration the amount of people that live in each of these spaces, there's only actually a few areas that are real hotspots for network performance events. These dark purple areas now are areas that don't really have anyone living there, but have got lots and lots of network performance events. So areas we might want to look at for improving infrastructure, for example, because they're performing particularly bad. Now, something else we might want to do as a telecommunications company is inspect our app data from customers in the field. What is really important is understanding how well our network is performing against how well we predict and say that it will perform. So when customers come to a provider, they expect that they will receive 3G or 4G at certain locations. So we need to be really sure that we are actually providing that performance that we say we're going to. A way we can do that is we can actually inspect app data we're collecting from customers in the field of how well the network is actually performing. So what we might want to do is compare this data set, which is just a location and a radio frequency score in dB called RF value, against a proposed data set that we have calculated using a radio frequency propagation tool that we use, so that we can sanity check what we're proposing to potential customers. So the first thing that I'm going to do to compare the two is I need to put them into a common geography so that I can compare them. So I'm actually going to spatially aggregate this data set into the postcodes as well. This time, rather than just styling by the count of app data, I'm going to style by that RF value, and I want to calculate the average per postcode. So count up how many of these fall into each postcode, and for the 6 or 7 or 10 that fall into each postcode, what is the average RF value that we're getting back from our customers in the field? And what we get is a really nice image here of the amount of how well, each of these postcodes are performing in terms of RF value. So something that we can do in Insights is we can actually consume non-spatial data. We can add tabular data, and we can join that to spatial data sets to then map them out. And that's really important when it comes to pulling in data from things like Excel. So in this instance, I actually have our proposed performance data in an Excel spreadsheet, which I'm going to add now. So I just go to Add Data, browse to Excel or CSV, browse my computer, and choose this RF value books. Now this has within it just the postcode name and how well we predict we should be performing as a network in each of those. What I can then do is use the Create Relationships tools to combine that tabular data to the spatial data I have, and also pull across some of that information like that proposed RF value. So firstly, I'll select our data set that I want to join the tabular data set to, and then I'll select that table that I've just added. Now it's clever enough to understand that two of these attributes have a commonality. They're both called ID. If that is the case, it automatically joins them up. If you want to join by a different identifier, then you can go into the edit in here and select a different one if you want. I don't need to, so I'm just going to click Finish, and then it's going to go off and join these two data sets together. Now what I then get is a new data set here in the table of contents that has not only the data within this map here, but also an additional couple of fields from that Excel spreadsheet that we just joined, such as average RF value, and that's what we're really interested in. Because now we've got two RF values. We've got one which was calculated from the app data, which we aggregated here. So genuine how the network is performing out there, taken from customers, versus the average RF value we have from our propagation tools that were predicting how well it should perform. So now we can actually compare the two. The way that we do this is if we go into the data table, we can actually edit the raw data from within Insights itself. We can even do things like add new fields. So if I add a new field and call it RF difference, and this field is going to be equal to the sum of the average RF, so how well is our network performing according to our customers, minus the average RF value, which is the value that we predict that the network should be performing at. And if I run that, then I will get the difference between those two in a new field here. The closer to 0, the closer we are seeing actual performance against predicted performance, and then positive numbers, the better we're performing, negative numbers, the worse we're performing. Now the really nice thing about this is because we've joined that tabular data to a spatial data set, we can actually now start to map this out. So if I just put in these polygons again just onto a map, and then what I'm going to do is I'm going to color those by that new field that I just created, RF difference, and I'm going to change this so that it makes a little bit more sense. If I change it so we're drawing it by color, and then go across to the palette, at the bottom of the palette we've got some nice color templates that really show the difference from 0. So 0, negative, 0 to positive. In this instance, 0 will be represented by yellow, negative values by red, positive values by green. So now we've got a really simple map that's showing exactly what we need to look at from a mobile telecommunication company point of view. We've got areas in yellow that we're absolutely fine with. What we're predicting we're seeing in the field. We've got areas that are quite interesting in green, where the network's actually performing better than we're predicting using our tools. And then most importantly, the areas in orange and particularly red, where areas aren't performing as well as we're predicting. So this is areas where customers are not necessarily getting the experience that they signed up for. And this is areas we might want to invest in terms of new infrastructure or better equipment to make sure that that quality of experience is better and is what we say it is, both from a customer experience point of view, but also from a regulation point of view to Ofcom. We need to do as well as we're saying we're going to do.